Hello dear students, welcome back to our class. So I'll be discussing about plotting inequations in today's lecture, and I'll give you a brief idea about the graphical solution of a linear programming problem. So say I consider the inequation, say twice x plus 3y less than or equal to 6. Okay, I want to plot this the region of the xy plane which satisfies these inequation. Okay, so let us consider a smaller or easier example, x less than or equal to 5. Okay, so which portion of the xy plane represents x less than or equal to 5? Okay, so let me just try out this diagram. Say this is your x-axis, this is your y-axis. Okay, x less than or equal to 5. So let me mark some points here: 1, 2, 3, 4, 5. So x less than or equal to 5, which region of the xy plane will satisfy x less than or equal to 5? Okay, so to understand that, what we will do, first we will plot the equation corresponding to this x less than x is equal to 5. Okay, so the equation will be somewhat like this: x equal to 5. In the last class also I had told you x equal to k represents a line which is parallel to the y-axis. Okay, so this is the line x equal to 5. Okay, this line represents x equal to 5. Okay, now if I select a point in somewhere here, okay, some points here, so for these points, what are the values of the x coordinates? Okay, suppose for this point the value of the x coordinate is something like, say, a comma, say y coordinate is y1, right, or say a1 y1. For this one it is suppose a2 y2. Okay, for this one it is suppose a3 y3. Okay, and I choose some points here. Okay, say this is b1, say y or z1. Okay, b2 z2, like that. So what is the difference between the points chosen on this side and this side of the line and on that side of the line? So on the left side of this line, you can very well understand this. As we go towards the left, the value of x actually decreases. Okay, that is the property of, or that is the convention that we use in plotting graphs, right? On towards the left of the number line, or towards the left of the x-axis, the values of x keep on decreasing, and towards the right the values of x keep on increasing. Okay, and similarly for y, towards the upward direction, the values of y keep on increasing. Towards the downward direction, the values of y keep on decreasing. Okay, so for any point here on the left of this x equal to 5, the value of x is actually less than 5. Okay, so for any points here, the value of x is actually less than 5, and for any points on the other side, on the right side, the value of x is strictly greater than 5, and for points which lie exactly on the line, the value of x is exactly equal to 5. Okay, so if I want to denote the region of the xy plane which satisfies this inequation x less than or equal to 5, so what is that region I should plot? Okay, so this is the y-axis, this is the x-axis. Okay, this line is x equal to 5. Okay, so the region of x-axis which satisfies the region of xy plane which satisfies this inequation is this region, the left region. Okay, anywhere, so we can just shade it, right? So anywhere on the left of this line, this inequality is always satisfied. Okay, so this line x equal to 5 divides the xy plane into two parts. Okay, one is x less than 5, another is x greater than 5. Okay, so in our LPP solutions you will often encounter this type of inequations. Then you have to choose the correct region, okay, which is represented by this equation. Okay, say I give you another one, say y is greater than or equal to 7. Okay, so how will you plot this particular inequation? Okay, so this is, say, y axis, so this is the x axis. So here this is x, this is y equal to 7. Say I make some equal markings here, 1 2 3 4 5 6 7 8. Okay, so 7 is somewhere here, right? So first I will plot the line corresponding to y equal to 7. Okay, what is that line? So this is the line which corresponds to y equal to 7, right? This is the line which corresponds to y equal to 7, right? Now I will see what is my inequation. Okay, my inequation says that y is greater than or equal to 7. So which region of the xy plane? So this line divides the xy plane into two parts. One is this part, another is this part. Okay, so this is one part, and this is the other part. Okay, so y greater than 7 is in which portion? I told you, as we go upwards, value of y increases. Okay, so y here the value of y is 7, this position value of y is 7, so in the upward direction the value of y will increase. Okay, so y greater than or equal to 7 is represented by this region of the xy plane. Okay, this region of the xy plane represents y greater than equal to 7. Okay, so these things we have to keep in mind. Okay, now let us go to this twice x plus 3y less than or equal to 6. Okay, so how do I represent this particular region? Okay, so what I'll do is, first we will draw the line twice x plus 3y is equal to 6. Okay, so I told you how to draw the line. We have to convert it to the intercept form, x by 3 plus y by 2 equal to 1. So immediately I can draw this line. Okay, say from here to here, and from here to here. Okay, suppose I have drawn the axis first. So this is the x-axis, this is the y-axis. Okay, and I make some equal markings here. So it's very important to make equal markings, otherwise you will not get the correct diagram. Okay, right, so it's x by 3, so let us make some equal markings here. X by 3, so x 3, 1 2 3. Okay, so x by 3 and y by 2. Okay, so 1 2. So this is a line which passes through this 2, sorry, this is a line which passes through this 2 and 3. Okay, this line passes through 2 and 3, right? So this is the straight line actually. Okay, this is the straight line which passes through 2 and 3. So twice x plus 3y equal to 6. Okay, but I need to find out, or I need to denote the region which satisfies this particular inequation. Okay, this inequation. So this line divides the plane into two different parts. One is this part, another is this part. Okay, so which part satisfies this inequation? Okay, how will I find it out? Okay, so of course you can one way of finding it out is you express this as this y in terms of x. Okay, so it's something like y is less than or equal to 6 minus twice x, okay, by 3, right? Y is less than or equal to 6 minus twice x by 3, okay. So y equal to 6 minus twice x by 3 is this line. So y less than 6 minus twice x by 3 will be the line, the portion that is below, okay, because the value of y will decrease as we go down, right? So y less than or equal to 6 minus twice x by 3 will represent something below this line, okay. So this region is below this line, okay. This is one way of doing. Another way of doing is you just compare, or you just locate in which region the origin lies, okay, whether the origin satisfies this inequation or not, okay. So any point in this particular region which satisfies this, okay, means if we are able to find a point here in this region which satisfies this, then the whole region will be this particular region, okay. Similarly, if you are able to find a point here which satisfies this inequation, then the whole region will be in this region, okay, because there are only two possibilities, and the straight line will divide it into two parts, either this part, okay. So in one part y will be greater than this whatever it is, another part y will be less than whatever it is, okay. So there are only two possibilities. So the easiest way to locate the region is you check whether origin satisfies this inequation or not, okay. Whether origin that is, what is origin is 0 0 satisfies, whether the origin satisfies the inequation, okay. So this is what we need to check, okay. So put it here, 2 into 0 plus 3 into 0, okay. What is that? 0, and 0 is less than or equal to 6. This is true, okay. 0 is always less than or equal to 6. This is always true. So origin satisfies this inequation. That means the portion of the plane which contains the origin is the region represented by twice x plus 3y less than or equal to 6, okay. So this is the region represented by twice x plus 3y less than or equal to 6. So just find out whether origin satisfies this inequation or not. So the region where origin lies will give you the answer if it satisfies. If it doesn't satisfy, then the region which does not contain the origin will give you the answer, okay. So let us try another one. Say twice x minus 3y greater than or equal to 6, okay. So how will I plot it? So first I will plot the graph of x by 3 plus y by minus 2 is equal to 6, okay. I will plot this graph first. Let us plot this, okay. So I am doing it in a rough way. X by 3 and y by minus 2, okay. So y is somewhere, say here, and x is somewhere here, say, let's say, okay. So say this is the graph, okay. Let me just increase its size. Okay, yeah, okay, whatever it is, no, I don't want it that way. I wanted this, yeah, okay. So almost, say x by 3 and y by minus 2 is equal to 6. So this is the line which is represented by the equality. Now I want to find out which region represents this one, okay. So I'll test whether the origin satisfies this inequation or not. So 2 into 0 minus 3 into 0, what is that? This is 0, and this is greater than or equal to 6. This is false, okay. This is incorrect. 0 is not greater than 6, okay. This is false. So that means origin does not satisfy this inequation. So the region which contains the origin is not represented by this. So the region will be the region which doesn't contain the origin, okay. So twice x plus y greater than or equal to 6 is represented by this, okay. So you can have a check also. I can always write this one as, if I interchange the sides, it's y is less than or equal to twice x minus 6 by 3. Okay, so y less than this, y equal to this is this, so y less than will be somewhere here, this region. Okay, so that will also you can check, right? So this was about plotting inequations. Okay, so I hope you can plot several types of inequations now. Let's say something like minus x plus 4y is less than or equal to yeah, or say it's greater than or equal to, right? Minus x plus 4y is greater than or equal to 8. Okay, okay, so let us plot this. Minus x plus 4y is greater than or equal to 8. Okay, so this is the x-axis. So I'll need something like x by 8, x by minus 8. Okay, I need minus 8, so I have to take the axis somewhere here, so it will be easier to plot. X by, because the inequation here is x divided by minus 8 plus y divided by 2 is greater than or equal to 1. Okay, so x by minus 8 may be somewhere here, minus 8 is maybe somewhere here, and 2 is somewhere here. Okay, so let us plot this line. Okay, so this is the line. Okay, yeah. Okay, so this is the line x plus minus x plus 4y equal to 8. Okay, now just check whether origin satisfies this or not. 0 plus 4 into 0, so that is 0. So 0 is greater than or equal to 8. This is false. Okay, so origin does not satisfy this. So origin lies here. So the region is the region which doesn't contain the origin. Okay, so the region is this actually. Okay, so you can see it from this also. Y is greater than or equal to 8 plus x by 4. Okay, so obviously this region is the required region. Okay, clear? I hope it is clear. Okay, so now suppose I want the region that is represented by twice x plus 3y less than or equal to 6, and okay, both the regions together. Okay, and say x less than or equal to 1. Okay, or twice x plus 3y less than or equal to say 12. I will just increase this. Twice x plus 3y less than or equal to 12, and x is less than or equal to say 3. Okay, so these two inequations together represents which region in the xy plane. Okay, so let us plot this regions, right? This is x-axis, x-axis, okay, and y-axis. Okay, so first let us plot this. Twice x plus 3y less than or equal to 12. So this means x by 6 plus 3y by 4 is equal to 1. X by 6. Okay, so let us assume some markings here. 1 2 3 4 5 6 7. Okay, like that. Say here also 1 2 3 4 5 6. Okay, so x by 6, x by 1 2 3 4 5 6. Okay, x by 6 is this, x by 6, and y by 4, 1 2 3 4. Okay, so say this is the line which represents the first equation. Okay, so let me put it here. Maybe I need to rotate it a little bit. What happens? It doesn't rotate. How do I rotate it? Okay, leave it. Okay, so suppose this is the line. Okay, I'm not being able to rotate it now. X less than or equal to 3, what does it represent? X is equal to 3 is represented by this particular line. Okay, this line represents x equal to 3. Okay, so now let us test which region is represented by which one. Okay, so twice x plus 3y less than or equal to 12, you can just check it whether origin satisfies this region or not. Twice x into 3y, so this is 0 less than or equal to 12, this is correct. So the region which is towards the origin will satisfy this particular inequation. Okay, so this region, anything which contains the origin. Okay, so this is the region corresponding to twice x plus 3y less than or equal to 12. Okay, now x less than or equal to 3. Okay, x less than or equal to x equal to 3 is this, and I had told you x less than 3 means it will represent the left portion. Okay, so anything on this side will be representing the x less than or equal to 3. Okay, so which portion represents the common the region that is common to both of this region? Okay, so from the diagram itself you can see the portion where there are both the markings, both the green marking and the yellow marking. Okay, that particular portion represents the, okay, so let me just mark it for your convenience. This particular region, it represents the intersection of these two regions. Okay, intersection of these two regions, right? So this is the common portion which is represented by these two inequations. Okay, so let me show it in a software so that you can understand it better. GeoGebra. Okay, yeah, so here you can see, so let me plot twice x plus 3y less than or equal to 12. So that was the line, this is the line through 2 points, x by 6, right? X by 6 and y by 4. Okay, so this is the line which is represented by this, sorry, and another line is x equal to 3. Okay, so x equal to 3 is, say, this line, x equal to 3. Okay, so one portion I had told you it was something like this, twice x plus 3y less than or equal to 6. So it was something like this. Okay, it goes actually, so for the sake of representing it by colors I am doing it like this. So anything on this side. Okay, and this portion, x less than or equal to 3, is anything on this side. Sorry, it is anything on this side. Okay. Sorry. This somewhere here, here. Okay, so anything on this side. Let me just change the color. Okay, so this is better. So that portion was, this portion is represented by this brown color. Okay, and this portion, x less than or equal to 3, is represented by the blue color. So from here itself you can see which region satisfies both the inequalities. Okay, so this will actually continue like that, right? So the region which satisfies both can be marked this way, this, okay, this, then this, okay, and then this, something like this. Okay, this region, this particular region satisfies both the inequalities. Okay, right, this pink portion, they represent both the inequalities, right? Okay, so that's how we deal with inequations. Okay, so if there are several inequations, we can always easily plot them. Okay, say I write something like twice x minus 4y less than or equal to 12, x greater than or equal to 0, y greater than or equal to 0. Okay, so in that case, what portion will it represent? Okay, so let us see. In that case, it will represent certain regions in the xy plane. Okay, so twice x minus 4y less than or equal to 12, that is x by 6, yeah, maybe somewhere here, x by 6, and y by minus 3. Oh, sorry, it will go this side, so y by minus 3. So let me just shift it up, maybe here, and this one, let me shift it, say x by 6, y by minus 3, somewhat like this. Okay, less than or equal to 12. Okay, so origin satisfies this inequation because 0 is less than or equal to 12. So the portion above this origin will represent the line, right? Okay, right. So the portion above, let me just mark it in blue. Okay, so this portion will represent the inequation. Okay, but here we have two more inequations, x greater than or equal to 0. So x greater than or equal to 0 is represented only in this region, right? X greater than, oh sorry for that, x greater than or equal to 0 is represented in this region. Okay, this side, the right side of y-axis, right? So this region represents x greater than or equal to 0. And yeah, even this portion, x greater than or equal to 0, is this. Okay, and y greater than or equal to 0 is represented by this region. Okay, anything above y-axis, anything above x-axis. Okay, so this portion, right? This is not there. Okay, this is not there, right? So which region represents all these three? Okay, in which region all the three inequations are satisfied? So you can easily see the portion which contains all the markings. Okay, so obviously let me take a black color. So this region, actually it goes that way also. So it is actually bounded by these things. Okay, so this particular region, so it keeps on going that way. Okay, so this region is the required region which satisfies all these inequations. Okay, so let me draw it nicely again. So in exam you don't have to mark so many things, just remember, use a pencil. Using a pencil you do the rough thing and just mark the final portion. Okay, so your question will require you to answer the feasible region, which region satisfies these inequations. Okay, so you just mark the particular region which ultimately you get, right, after marking everything. So no need to mark so many things. it will make the diagram very clumsy. Okay, so once you understand that this twice x minus 4y greater than less than or equal to 12 represents the portion above, right, you can just mark it this way, right? This way it's better to mark so that you can understand it, that twice x minus 4y less than or equal to 12 represents the portion above this line. Okay, and then x greater than or equal to 0, it represents the portion on the right side of the y-axis. This is x greater than or equal to 0, right? And y greater than or equal to 0, this is represented by these arrows. Okay, so the portion above x-axis. Okay, so immediately next you can identify what is the required region. Okay, what is the required region? Required region will be something like this. Okay, so this portion satisfies the common region. Okay, all those inequations are satisfied in this particular region. Okay, right? So that is how we write these inequalities, or we plot these inequations. Okay, in the system of inequations. Okay, right. So in order to solve an LPP graphically, so we have this graphical method of solution, graphical solution of LPP. Okay, so say I consider some LPP like minimize z equal to 3x plus 7y, subject, or say maximize. Let us start with the maximization problem, subject to the constraints, say twice x plus 4y is less than or equal to what should I write, say 8, or not 8, let me take a larger number so that it's easier to plot the graph, say 12. Okay, then something like x greater than or equal to 1. Okay, and x plus y is less than or equal to 3. Okay, so let us see how we can plot this the feasible the how we can plot the region which satisfies these constraints. Okay, we will see the optimality test later on, maybe in the next lecture. First let us plot this feasible region. Okay, which region satisfies all these plots, all these inequations. So the first inequation that we have, or the first constraint that we have, is twice x plus 4y less than or equal to 12. Okay, so if we write it, so it's x by 6 plus y by 3 is less than or equal to 1. Okay, so x by 6, say somewhere here, but of course here I have to be careful while marking the things. Okay, say 1, 2, 3, 4, 5, okay, 6, like that. So here also 1, 2, 3, 4, 5, 6, 7, like that. Okay, so this is x by 6 plus y by 3, x by 6 plus y by 3. Okay, so something like this, and then this is actually less than 1. Okay, so the origin here origin satisfies this inequation, so the feasible or the inequation represents this type of this region. Okay, this side, region of this side. The other one is x greater than or equal to 1. Okay, so for x equal to 1 we will plot the line. Okay, we plot the line corresponding to x equal to 1, right? So you plot this, Control Z, sorry, what happened? Yeah. Okay, you plot the line corresponding to x equal to 1. Okay, so something like this. So x greater than or equal to 1 is represented by which region? X greater than 1 is represented by this region. Okay, the region on this side. Okay, and the next inequality that we have is x plus y is less than or equal to 3. So x plus y less than or equal to 3 means x by 3 plus y by 3 is less than or equal to 1. So again origin satisfies this inequation. So let us plot this line first. The line will be 1, 2, 3. The line will pass through x equal to 3 and y equal to 3. Okay, so this is the line which yeah, so this is the line, and origin satisfies this, so the region will be this region. Okay, the region which contains the origin. Okay, so now out of all this, which region is common to all the things? Okay, all the inequalities. So you can easily see this particular region. Of course, we have another inequality here. This one, x greater than or equal to 0, y greater than or equal to 0. The non-negativity constraint is already there, so we have to take care of that also. So the region will the feasible region that we talk about. Feasible region means the region in the xy plane which contains the solution of the given problem. Okay, so so since all the inequalities are satisfied in this region, so our solution will lie somewhere here. Okay, so that is why this region is actually called the feasible region. Okay, feasible region. Okay, so the region in the xy plane which contains or which satisfies all constraints of the given LPP, including the non-negativity constraint. Okay, so our feasible region is this. Okay, so in your exams you have to mark it this way, this feasible regions. Okay, and of course you can write these lines. This is x equal to 1, this line is your x plus y equal to 3, this line is your twice x plus 4y equal to 12. Okay, of course you mention these things. This is x-axis, this is y-axis. Okay, so this region contains the feasible solution. Okay, solution is somewhere here, and how to find out the solution we will do it in the next lecture. So for the time being, you try plotting these inequations. Okay, or you try finding out feasible regions. Okay, find feasible regions for, say, number 1, maximize z equal to twice x plus 7y, subject to, say, x plus 4y is greater than or equal to 8, y is less than or equal to 5, and say twice x minus 6y is less than or equal to 6. Okay, x comma y greater than or equal to 0. So try finding out the feasible regions of this. Okay, another one, say you take any problem like minimize z equal to 6x plus 11y, subject to the constraints twice x plus or say 3x plus 4y less than or equal to 12, x plus or say x minus y is greater than or equal to 2. Okay, x comma y greater than or equal to 0. Okay, so for this 2 you try to find out plot the feasible region. Okay, so you can plot the feasible region and you may send it to me in your Google Classroom also. Okay, I'll give it as an assignment most probably, so you can just, if you are interested, you can just reply that in the or submit your assignment. Okay, so that I can understand that you have understood. Okay, so thank you for today. Next day we'll continue.